Welcome to our presentation on life expectancy. We are Group 12 with Shrehan, Sam, Harper, Taijing, and Christy. And our data consists of developed and developing countries with varying degrees of life expectancy, which is dependent on various factors which we try to determine using our analysis techniques. This project will help in suggesting a country which should be given importance in order to improve the life expectancy of its population. In Part A, we will discuss the objectives we want to focus on, the data source where we obtained our data, the variable descriptions, descriptive statistics, then our findings. And Part B will be discussed with Sam. Let's begin with the descriptive analysis on our variables. The objective of this section is to understand the statistics of our variables so that we can shed more light on the variables we want to further analyze so that we can determine which variables might be helpful in predicting life expectancy. The following data set, which is related to life expectancy with health factors for 184 countries, has been collected from the World Health Organization Data Repository website. It corresponds with economic data that was collected from the United Nations website. And we have decided to focus on data only from years 2000 and 2015 for 184 countries for economic mortality and other health-related analysis. Here is a description of all of the variables we used. Country and status, you can see, are the only qualitative data types, and the rest are quantitative data types. The data is focused on the population of interest. This does not represent a random sample. It's actually two samples taken from the year 2000-2015 for the 184 countries. If we take a look at this time series map, you can see that over the years, the average life expectancy has improved in the most developed and developing countries. You can see that with the darkening of the shading colors in this map. And taking a look into more details, these histograms illustrate the median and mean of life expectancy on developed countries, which are higher than the developing countries. It is more likely that citizens' life expectancy will be in the ages between 77 to 80 in 2000, while in 2015 is the ages between 82 to 85. However, we can also see that the range of developing countries is larger than developed countries, which means that the developing countries have a wider range of ages of how long they live for. And this pivot chart will show that irrespective of the region of the country, the life expectancy is always higher in 2015 than it is in 2000. And also that even in 2000, developed countries had higher average life expectancy than the developing countries. You can also see that adult mortality, and if you focus on the maximum values from 2000 and 2015, you can see that the probability of adult mortality is lower in 2015 than in 2000. And the mean and median number of years in school in 2015 are higher than 2000, which means that the education coverage has improved over the 15 years. Now, focusing on the percent on polio immunization among 1-year-olds, the mean is higher in 2015 than in 2000, which means that there were a high percentage of polio immunizations among 1-year-olds in 2015. Diphtheria also shows that the mean is higher in 2015 than 2000, which represents that there's a higher percentage of immunizations for diphtheria among 1-year-olds in 2015 than 2000. And the following charts will show the economic attributes like GDP, current health expenditure, and percentage of GDP. You can see that they all increase over the 15 years, and it means that all the governments improve their financial investment in prolonging citizens' life expectancy. And based on all of this, we concluded that life expectancy of both developing and developed countries has increased in the 15 years, and developing countries' progress is more outstanding. The government's financial investment to health and immunization coverage has also improved in the 15 years. Adult mortality dropped, the rates have dropped, and more countries' body mass index lies within the normal weight range, and schooling has increased, which means education coverage has improved.
Hi, I'm Sam, and I will be covering the remainder of our analysis, which is part B. In part B, we will be analyzing some scatter plots which we have generated of individual variables versus life expectancy in the year 2000 as well as the year 2015. And we will be seeing the correlation matrix of these variables to see which of them are highly correlated to life expectancy, as well as carry out multiple regression and test a hypothesis. In a simple linear regression of life expectancy versus adult mortality in the year 2000 as compared to the year 2015 shows us that adult mortality is a better predictor of life expectancy in the year 2015 than it is in the year 2000. And it also shows that they have a linear relationship. The scatter plot we devise for schooling versus life expectancy, as schooling being a predictor of life expectancy. We see that with an accuracy of zero point 0.6 in the year 2015, every additional year of schooling would increase life expectancy by 1.98, whereas in 2000, with an accuracy of 0.46, every additional year of schooling would increase life expectancy by a factor of 2.23 approximately. Then we went on to carry out our simple linear regression of life expectancy versus body mass index, and we see that with the accuracy of 0.37 and 0.27 respectively for the years of 2000 and 2015, that every increase in percentage of average BMI, every increase in average BMI of a country actually increases the life expectancy or by a factor of 0.33 in the year 2000 and by a factor of zero point 0.2 in the year 2015, which is quite contrary to what we were expecting. And when it comes to our linear regression of life expectancy versus alcohol, we see that alcohol consumption, it shows us that it has a very low accuracy, and alcohol is not in general a very good alcohol consumption is not a very good predictor of life expectancy, as we can see that the points are extremely far away from the line, and also that the R-square value is low, and that shows us that alcohol isn't really a good predictor, which which we will be testing out further down in our analysis. Now proceeding to the scatter plot of life expectancy versus diphtheria. With a high accuracy of zero point 0.5 in the year 2000, we can say that with each increase in percentage of children under 1 year old who are vaccinated who are given the diphtheria vaccination, the life expectancy of that country would increase by a factor of 0.378. Whereas with a slightly lower accuracy of 0.24 in the year 2015, for every additional percentage of children vaccinated with diphtheria, the life expectancy of that country would be going up by by a factor of 0.29. Now proceeding to a simple linear regression of life expectancy versus a GDP, and this actually has a low accuracy, and it shows us that GDP isn't a really good predictor of life expectancy, and even if the R-square value was high, the factor by which the life expectancy would increase with every increase in per capita GDP would be very low. So earnings is not a very good predictor of life expectancy. And when it comes to seeing the average life expectancy versus the current health expenditure of with the current health expenditure as a percentage of GDP in the year 2000 as compared to the year 2015, we can again see that uh, with a low accuracy of 0.04 and 0.08 respectively, um, current health expenditure is not a really good predictor. Current health expenditure as a percentage of GDP is not a really good predictor of life expectancy. When we see current health expenditure on its own per capita versus life expectancy, we see that with an accuracy of 0.34 and 0.25, that current health expenditure is a predictor of life expectancy. But again, with each additional dollar per capita spent per household on current health expenditure, the factor by which life expectancy would increase will be by a meager factor of 0.0028 or 0.0066 in the year 2000. After this, we carried out some multiple linear regression of life expectancy versus current health expenditure and the status of a country. And in this, we use current health expenditure We used a dummy variable which showed whether the country was developed or developing, and we also used an interaction variable where we multiplied the dummy variable with the current health expenditure. As we can see that the interaction variable is a better predictor of life expectancy as compared to the current health expenditure on its own, because because the interaction and dummy variable, the interaction variable which we created between the dummy and current health expenditure has a much lower p-value as compared to the other one, as compared to current health expenditure, which is 0.22, and we can see that with the adjusted R-square value of 0.36 and 0.50, that life expectancy um, in developed and developing countries in both the years 2000 and 2015, approximately with an approximate value of 12, that difference of 12 between developed and developing countries, that would mean to say that the developing countries would have life expectancy 12, approximately 12 lower than those of developed countries in both the years 2000 and 2015. And proceeded to carry out multiple linear regression of life expectancy versus current health expenditure as a percentage of GDP. As we can see that the R-square value is pretty low, and the factor by which uh, life expectancy would increase based on the current health expenditure as a percentage of GDP is also pretty low. But and also we have high p-values, so these variables are not really strong predictors of life expectancy. Now we proceeded to create a correlation matrix of all these variables to understand that what is the interaction or what is the correlation between these variables and which variables are highly correlated with which. This gave us the results that the correlation matrix of variables keeping a plus minus zero point 0.5 interval, the variables which we have highlighted, which is adult mortality, BMI, polio, diphtheria, schooling, and per capita income in US dollars for the year 2000, shows us that all of these variables, adult mortality, BMI, polio, diphtheria, schooling, and per capita income, are highly correlated with life expectancy. Whereas in the year 2015, as we can see that due to obvious reasons such as progress in healthcare and improvements in technology used in healthcare, that we can see that for those possible reasons, I mean, um, it does not imply correlation matrix does not imply causality, but it also shows that diphtheria is no longer highly correlated with life expectancy, and neither is polio. These values have reduced by a bit, and it shows us that in the year 2015, adult mortality, BMI, schooling, and current health expenditure and government expenditure on health are highly correlated with life expectancy, and this fact can be tested further using our regression models. Now, after carrying out stepwise linear multiple regression without using dummy and interaction variables for the year 2000, we get the following equation, which is at the bottom of the screen, to show us the equation which can be used to predict life expectancy. And in this equation, we can see that polio and diphtheria have a slightly higher p-value as compared to the others, whereas schooling has a very high coefficient, and it shows us that for every additional year of schooling, the life expectancy would go up by a factor of 0.722, which is and with an accuracy of 0.7616 with an adjusted R-square value of 0.76. It says that this is a fairly accurate model, and we could actually say with say that schooling has a strong impact on life expectancy. And the same thing, we carried out the stepwise linear multiple regression with dummy variables for the year 2000, and it shows us that using the status of a country as a dummy variable, holding all other variables constant, the life expectancy of developed countries are higher than developing countries by 4.45 each year. And also, proceeding to the next slide, we have that carried out multiple stepwise regression with dummy and interaction variables, and this gives us the equation that life expectancy uh, is actually has a higher that developed countries have a much higher life expectancy as compared to developing countries, and the adjusted R-square value for this model is 0.57, and it shows that diphtheria actually reduces the life expectancy. Every increase in percentage of children who are vaccinated with diphtheria increases the life expectancy in developing countries, whereas that reduces the life expectancy in developed countries. When we carried out stepwise multiple regression without dummy and interaction variables, it shows us that with an accuracy of 0.79, that the equation for life expectancy is as follows, and it shows that uh, for every additional year in schooling, in the year 2015, the average life expectancy of that country would go up by a factor of 1.206 for every additional year in schooling, of average of the entire country. And we also carried out the similar stepwise multiple regression with dummy and interaction variables, and we came to the conclusion that in developed countries, the life expectancy um, uh, would be uh, uh, would be higher than that for developing countries, and adult mortality would not really change that factor by much. Um, and then we proceeded to carry out our test of our hypothesis, which was that basically the mean life expectancy in the year 2015 is higher than the mean life expectancy in the year 2000. And after carrying out that testing that hypothesis, our null hypothesis, which would mean that the mean life expectancy or the difference of means of the life expectancy would be greater than zero, as whereas it turned out to be that it was lesser than zero. And with the low p-value, this shows that the null hypothesis can be rejected, which means that we have evidence to suggest that the mean life expectancy in the year 2015 is higher than the mean life expectancy in the year 2000. After this, we, as an extra step or going the extra mile, we tried to find a linear model for using z-score transformation, and this gave us, I think, one of the highest R-square values we have been able to attain till date. This helped us account for outliers as well, and with the low p-values of our variables, helped us predict with higher accuracy, and this model for the year 2000 gives us a uh, R-square value of 0.76, whereas the one for the year 2015 gives us the highest R-square value of 0.84. And in our conclusions, I would like to conclude by saying that the life expectancy has a positive relationship with immunization coverage, with the number of years of schooling, BMI, and current health expenditure, and that it has a negative relationship with adult mortality. And the status of a country is very good at determining life expectancy, especially when used as a dummy variable. Thank you for your patience, and thank you for, and we hope you enjoyed our presentation.